So let's apply some of the ideas of inverse trig functions and their related domains. So we're restricting our domains, so because we want these to be functions that we're dealing with, and we can use that to find values. So inverse sine of 1 on root 2. Well, when we've looked at this one in the 2-unit course or extension 1 problems before, really we know we could get a general solution to this, and that, like, technically there's an infinite number of solutions for inverse sine of 1 on root 2. But when we want to restrict our domain and get a function, which means that every x value has one y value, and vice versa. So we have to restrict our domain of our inverse of our functions. So if we're looking at the inverse sine of 1 on root 2, then we're going to restrict it to the first and second quadrant. So if it's positive, we're in the first quadrant. So that's where we're going to get the pi on 4 being our value there. So inverse cos of a half, well, inverse cos we restrict to the first and second quadrant, so we get a function. So inverse cos of a half will give us pi on 3, positive pi on 3. Inverse tan of 1 on root 3, again, we're dealing with the first and fourth quadrants to make it a function, inverse tan function, not just an inverse tan relation. So it's going to give us pi on 6, because that's what inverse tan of 1 on root 3 would give us as our related angle. Inverse sine of 1 will give us pi on 2. So we only want the 1 value. So it's only going to give us the 1 value. Inverse cos of 1 on root 2, again, first quadrant there, so pi on 4. Inverse tan of minus 1. Now, again, inverse tan we take in the first and fourth quadrant. So we're only looking at a value that might be positive there. If it's negative, it's going to be in the fourth quadrant. Inverse tan of minus 1 will be our related angle there, pi on 4, back into the fourth quadrant. So that's where we get the minus pi on 4 from, because it's only going to be that one value. We're not going back over here and going, well, that's going to give us a negative value as well. No, we're only one value allowed, because it's going to be a function. So for every x value, there's only one value, one y value. So that's where we get just the minus pi on 4. Inverse sine of root 3 on 2, again, first quadrant, because sine's positive in the first quadrant, and that's all we want to take. We don't want to take the second quadrant, only one value, so we get the pi on 3. And cosine of minus pi root 3 on 2, minus root 3 on 2. Now remember, cosine's in the first and second, because in the first and fourth, they're both positive. So they're only sine and tan we consider in the first and second for our inverse function. But for cosine, we're going to take the first quadrant and the second quadrant, because cosine's negative there. So because it's minus root 3 on 2, we're going to consider our related angle. So it's going to be a pi on 6 there. We go back from pi on 6, gives us that 5 pi on 6 in the second quadrant. Only the one value allowed. So we've got to keep that in mind. So some other problems. Well, what happens when we go in sine of an inverse sine of a function? Well, remember they're opposites. So we just reverse the process there. So sine of inverse sine of 3/8 would give us 3/8. Cosine of inverse cosine of minus 5 on 7, minus 5 on 7. So you can see what we're getting there. But what about when we go sine of inverse cosine of 3/5? Well, that's going to give us 4/5. Why is that the case? Well, consider this. If inverse cosine of 3/5 was, say, alpha. So let alpha be equal to the inverse cosine of 3/5. That basically means cosine of that angle alpha would be 3/5. If we drew up a triangle which signifies that, a right angle triangle, then our opposite side would be 3, our adjacent side is 3, our hypotenuse is 5, so our opposite would be 4 by Pythagoras' theorem, which means that sine of alpha then would be sine of this angle, which would be the opposite and the adjacent. Opposite and the hypotenuse. 4/5. That's where we get that 4/5 from. Okay, so that's what we've got to look at to do these questions. Inverse sine of 12 on 13, again, let that be equal to alpha. So sine of alpha is 12 on 13. So the opposite on the hypotenuse is 12 on 13. By Pythagoras, we get 5 there. Tan of alpha would be the opposite on the adjacent, 12 on 5. Inverse tan of 6 cosine pi on 4. Well, what's cosine of pi on 4? Well, that's going to be 1 on root 2. And root 6 on root 2 gives us root 3. Inverse tan of root 3 is going to give us pi on 3. Now some of those might sound simple. Remember, we're only dealing with one value though. We're restricting it so we're in the correct domain. And inverse sine of 2 pi on 3. Now this shows that sine of 2 pi on 3 will be root 3 on 2, but because our determination is that inverse sine is only going to be in the first and second quadrant, first and fourth quadrant. So where it's going to be a positive sine, so inverse sine of root 3 on 2, we're not just reversing this and going back to 2 pi on 3. That's outside of what our domain would be restricted to. So that's why our answer is just going to be pi on 3. Sine of 2 pi on 3 and sine of pi on 3 are the same. But we're going to restrict our domain around the origin. And that means that the sine pi on 3 gets the answer in this case. Because like inverse sine of 2 pi on 3, sine of 2 pi on 3 and inverse would give us 2 pi on 3 or pi on 3. We can get both values, but we take that because it's in that first or fourth quadrant. So that's how we're going about. So even if our values to start off with are outside the our domains that we normally take, when we go back and take our inverse sine or inverse cos or inverse tan, we're going back to our restricted domains of the function that we started off with.